In order to study the three trigonometric ratios as functions, first we have to generalize angle measures. So angles will have an initial side, which is a fixed ray of an angle. It will have a terminal side, which is the rotated ray of an angle. And we'll have something called standard position. And that's where the initial side is on the positive side of the x-axis and the vertex is at the origin. So this is an example of an angle in standard position. This green side is its fixed or initial side. This blue side is its terminal side. And when we define angles like this, they're said to be directed angles. That means angles with a sign. And counterclockwise is going to be positive and clockwise is going to be negative. And this is going to be in relation to the initial side. So if I look at that angle there, I can say, well, in this case, let's say it's about 120 degrees. And that's a positive 120 because I'm going counterclockwise. If I go clockwise, this direction, then the angle with the exact same terminal side is going to be negative 240 degrees. So if I go counterclockwise, it's positive. If I go clockwise, it's negative. Now, we get general angles by realizing that angles can take more than one rotation. So I could draw an angle that does this. It goes around full circle and then to the terminal side. So that little spiral of an angle there is 360 plus 120 or 480 degrees. And I can go around as many times as I want and get an angle as big as I want. Now, all three of these angles, the 120, the negative 240, and the 480, are said to be coterminal angles because they share a terminal side. And they occur when you have plus or minus multiples of 360 degrees or 2 pi radians. Now, speaking of radians, you should have learned a little bit about radians in geometry. And so I'm just going to do a quick review. This is the Greek letter theta, which we often use to denote angles. So theta is the ratio of arc length s to radius r, and that is a radian. It's a measurement of arc length in relation to radius. Now, 1 radian is defined as this. In a circle with radius r, and it's centered at the origin, 1 radian is a measure of an angle in standard position whose terminal side intercepts an arc of length r. So I have a radius of r, that arc length there is r, that's 1 radian. And with that information, of course, we can realize that 2 pi radians is going to be a full circle, which gives us a method of conversion. I know that 180 degrees is equivalent to pi radians, and so if I want to know some conversion factors, from degrees to radians, I take my degree measure and multiply it by pi over 180 degrees. I take this and I turn it into my conversion factor. And if I want to go from radians to degrees, I take my r radians and I multiply it by 180 degrees over pi. Now in this unit, we're going to be switching between angles and radians, and you have to know some benchmark equivalents. So you have to know what 30, 60, 90, 0, 45, what those degree measures are in radians and their counterparts along the unit circle. So now that we have a way to have any number be an angle measure, I can talk about generally defined trig functions. Now the trig functions you know are the ones that are related specifically to a right triangle, and we're going to look at them in terms of angles in standard position. So if I let theta be an angle in standard position and xy be a point where the terminal side of theta intersects with the circle of equation x squared plus y squared equals r squared. So I have some circle, its equation is x squared plus y squared equals r squared. And I have the terminal side of the angle hit the circle at x comma y. And with this information, I can define my trig functions. I'm going to say that sine isn't opposite over hypotenuse, it's going to be the y value over the radius. So the y value over the radius. Cosine is going to be the x value over the radius, and tangent is going to be y over x. And in doing this, we're going to start getting negative values of sine, cosine, and tangent. That's one of the differences between this type of trig and trig that's right triangle trig. You can have negative sine, cosines, and tangent because your point xy can have negative coordinates. So for example, this x value is negative, so its cosine and its tangent are going to be negative. If my terminal side was in this quadrant here, then yes, everything's going to be positive. But if my terminal side's down here, then sine and cosine are going to be negative and tangent's going to be positive. Now, one little factoid, if theta is in standard position and P is on the terminal side, so that's the point P, the coordinates of this point are defined as r cosine theta, comma r sine theta, where the radius is that distance from the origin to the point P. So that's how I can find quick points on a circle, is if I know the radian there, I can figure out the coordinates because it's r cosine theta, r sine theta. Now, why this is important? We like to simplify this a little bit. We like to use a unit circle, which you also learned in geometry. That's where the radius is 1, and when you have a radius of 1, then it simplifies the coordinates to the y value being just y sine theta, and x is just cosine theta. Now, something you didn't learn in geometry are the other 3 trig ratios, the secant, cosecant, and cotangent. And these are called reciprocal ratios because they are just reciprocals of the trig functions you already know. First, we have secant, and secant is 1 over the cosine. And in terms of that terminal angle drawing that I had earlier, it's going to be the radius over the y value. Cosecant is 1 over the sine, which is the radius over the x value, and cotangent is 1 over tangent, or the x over the y. And the way we abbreviate these, secant is going to be abbreviated SEC, and cosecant is going to be abbreviated CSC, and cotangent is going to be abbreviated COT. And so with this information, I can give you an angle in standard position and say, hey, find the 6 trig values of theta. So I want sine, cosine, tangent, secant, cosecant, and cotangent. And I start off, well, I know my x value is -4, and my y value is 3, and I know I can form a little right triangle with the terminal side, and I can figure out the value of r, which is going to be just -4 squared plus 3 squared square rooted, which is just 5. So now I have an r value, an x value, and a y value, and I can find my 6 trig values. So sine of theta is going to be, remember, the y value over the radius, which is 3 over 5. The cosine is going to be the x value, which is -4 over 5. My tangent value is going to be the y value over the x value, so it's 3 over -4. And then I can find the other 3 by just taking the reciprocals of these. So my cosecant, remember, is the reciprocal of sine, so it's going to be 5/3. My secant is going to be the reciprocal of cosine, so it's 5 over -4. And my cotangent is going to be the reciprocal of tangent, which is going to be -4 over 3. And now for a couple of loose ends. The first one is on vocabulary, and this one is particularly a type of angle called a reference angle, and these are acute angles formed by the terminal side of the angle and the x-axis. And these angles are super important because you find the reference angle when I ask you to find the sine, cosine, or tangent. You can just use the reference angle, and it makes it much easier. So if I have this angle right here, its reference angle is that little red angle. And if I have this big angle right here, right, it goes around, that's the reference angle. And if this angle goes all the way around there, then that is the reference angle. And the final loose end is an issue of notation. And I want you to realize that whenever you see sine squared theta written like that, it means you take the sine of theta and you square it. We just don't write the parentheses. We just put the square next to the sine. So make sure you know this notation is going to be very important for the next lesson.